Neutralizations of acids and bases for the net ionic equation lab. And, okay, here we go. We are going to take a look at, if I look at question number 3, it talks about barium hydroxide, which hydroxides typically indicate an OH, which is a base, and then it says nitric acid. Okay, and if I look at question number 4, I get barium hydroxide, which is a base, and sulfuric acid. So both of these are acid-base reactions, and there's a little trick to these. And if I think on the last page of the lab, you'll see probably the simplest of neutralization reactions, and that's when I take hydrochloric acid, or HCl, and combine it with sodium hydroxide, which is NaOH, and assume I'm going to have solutions of each one. All right, so looking at things, we can see that the H is going to combine with OH, and it forms H plus OH minus, or what we're going to call H2O, is a liquid, and then what's left is the Na combining with Cl, a salt. In a broad sense, this would be table salt, sodium chloride, but in a broad sense, salt is an ionic compound. So an acid plus a base forms water plus some type of salt. In this case, it's table salt or sodium chloride. Okay, now let's look at this. This was aqueous to begin with. This was aqueous to begin with. If I looked at my my solubility table, I'd see that all alkali metals are soluble. So it's clear to see NaOH is aqueous. I don't see anything about hydrogen on there, but assume in acids that these break up into H plus, and whatever the negative part would be, in this case, the Cl would be the minus charge. So an acid actually dissolves in water to form an H plus. Okay, and one of the definitions of a base is it dissolves in water to form OH minus. Okay, with that happening, it doesn't form a solid, but these ions don't remain separated. They actually combine to form water. And water by itself doesn't, it's a liquid, it doesn't break up into ions, at least to any significant extent. So we're going to call this H2O liquid there to indicate something went on. Now, what about the Na and the Cl? If we looked at solubility rules for this, we have an alkali metal, it's going to be aqueous. So really, the Na plus and the Cl minus are ultimately going to be spectator ions if we had to do a net ionic equation. So even though it isn't a solid precipitate, when you have an H plus combined with an OH minus, you say it forms H2O liquid, and you write it out that way. In this case, and in most cases, the Na pluses and the Cl minuses are aqueous both times. They're the spectator ions. So looking at what's crossed out, it's H plus OH minus forms H2O. And that's typical in a neutralization reaction, is that you get this H plus OH minus forming H2O. The acid cancels out with the base, forming water, and then the salt or the sodium chloride remains as spectator ions in solution. So this would ultimately be the total, or the molecular equation, the total ionic equation, and then after crossing out, I get to the net ionic equation. I'm going to just get away from the screen share. You see those problems, I think, in number 3 and 4, so you can work with those. And just a little visual of this, I think, might help. If I take some HCl here, I put a little in a test tube, it's a clear solution. And then I'm going to add some NaOH. Okay, we have a neutralization reaction, but can you see anything? No. However, let's say I'm just going to put a drop of phenolphthalein, which phenolphthalein is interesting. In a base, it's a little drop. In a base, it turns pink, but in an acid, it's clear. I don't see anything there. I'm going to put in the HCl. Nothing's going on. But I put in the base, NaOH, and I drop the base, and notice it's getting that pink color. I could drop a little more base there, get a pretty strong pink color. I think you can see that on the backdrop right there. So again, it neutralizes, it forms water. Okay, you don't see anything. Now, when I added extra base, it actually turned this color right here. So again, sometimes you don't see a reaction. There's something going on there with that neutralization. And I just wanted to provide that color backdrop. When I got to an excess of base, you could actually see that color change to show that there's something there that you don't ordinarily see unless you have like some indicator showing up. All right, numbers 3 and 4 were neutralizations. Hopefully that helps with that type of problem. Thank you.